they give you zeros and a separate point, you need to find that value of a. This mirrors the exact same thing that we did with quadratics when they were in intercept form, where we had to solve for that value of a given our two zeros for p and q. It's the exact same setup, but we just add one other part to it. Never have to worry about multiplying these out. I'm not going to ask that you do. You can leave it in that format with a, parentheses, parentheses, parentheses. Okay? So if I look at number 20, what I'm trying to do is fit them into this format of y equals a x minus p, x minus q, and x minus r, where p, q, and r are the zeros that are given to us. The x and the y values are just the extra point. So here we have zeros at -1, -4, and 4. So I have my 0 be +1, +4, and -4. All I'm doing here is I'm saving a step by not filling in x's and y's yet. My x and y value given to me are 0 and 3. So it's got to equal 3. A is here, so this is going to be 0, 0, and 0. Now, I'm going to trust the fact that we can do 1 times 4. This is 4. And then 4 times -4 is -16. So 3 equals -16a, which means a is -316. Yeah. So then my final answer becomes y equals -3/16 x plus 1, x plus 4, x minus 4. And what's nice is that when you get that far with this intercept form, you can easily check your answer by using your calculator. Let me show you. And this only takes a second to do. If you go to your y equals table and type in alpha y equals -3/16, and just type in the rest with parentheses, x plus 1, x plus 4, x minus 4. And if I go right to my table, what ordered pairs should be in my table? The 4 ordered pairs they gave us. So I got to go back up. Oops, sorry, I went too far. So we had zeros at so we have -1 and 0. Yay! -4, 0. Yay! 0 and 3. Yay! 4 and 0. Yay! That's just a way to check it. Because if the polynomial that we come up with is correct, it will incorporate all those ordered pairs in the table. So we didn't done goof. Okay? Does that make more sense? Do you have contacts? No. Okay. So you're gonna have to throw that pair out. Speaking from somebody who's had pink eye. I had double pink eye last Christmas. It was great.
It looks like your eyes are bloodshot.
It was awful.
Just, hey guys, are you okay?
Can you do number 46?
Your eyes are bloodshot.
Which one?
46.
Stop touching it.
I have to. It
No,
hurts bad.
you can't. Trust me, you can't.
It's like a
You
bruise.
can't. You have to believe me, you can't. The more you touch it, the more it's going to spread. You can't. You have to fight it. Every time, yeah, exactly. So every time you touch it, every time that you think you're going to want to touch it, stomp your foot.
Mosquito bites. No, we didn't. And we didn't
What was the
do-
one you said?
We didn't do 46. It was every other even and it ended at 44. And then
It wasn't the only one.
Yeah, it's every other even starting at.
That's good practice.
But I didn't work out too.
Nobody did it.
So,
I did it.
it's good practice. Do All right, so in this case here, we have a duplicated 0 at -2. Somebody did, so I can just do it anyway. It's fine. I have a duplicated 0 at 2. I have a 3, and then I have a -4i. If I have a -4i, what else should I have? Positive 4i. So right off the bat, knowing that you have a positive 4i, you might be able to tell right away what gives you that what term gives you plus or minus 4i. This will be x squared plus 16. And then here we've got x plus 2, x plus 2, x minus 3. And then it's a matter of multiplying all of that out. It's a lot of fun. So we have x squared, 4x, and a 4. X cubed plus 16x minus 3x squared minus 3248, right? Yeah. Now I gotta FOIL all that out. I'm just gonna rewrite this as minus 3x squared. And that was 16x. It was plus 16x, right? And then I have to FOIL out one more time. X to the 5th minus 3x to the 4th, 16x cubed minus 48x squared plus 4x to the 4th minus 12x cubed plus 3264x squared minus 96. 96 is 182. 192. 192. And then plus 4x cubed
Minus
64x minus 192. And a partridge in a pear tree.
Yes.
So, fifth degree polynomial, x to the 5th. You guys remember the little trick when you're putting combining like terms just to cross off what you're doing so you don't double count it? So I go to the x to the 4th, so I'll underline all of them, make sure I don't miss one. Negative, positive, and that's it. 16 minus 12 is 4, plus 4 is 8. Oh, thank you. So I was wondering where I missed one there. Negative 48 and 64 is 16, I believe. Yeah, 16 minus 12 then is 4x squared. (192 minus 64) 128. Is that right? Science. And a 192. So, if you get that, could you check your calculator to see if at least some of those zeros showed up? Yeah. Your imaginary won't show up because it doesn't calculate the imaginary ones, but imaginary? I don't know what I'm saying. But yeah, you can go back and check your zeros at least for a couple of them. For the -2 duplicated and the 3. So, hey, if you get 3 out of the 5, you might be on the right track. Hopefully, right? What else we got on those? These are fun. Once you remember how to add correctly. I know it asks a lot. Foiling these things. Curses, foiled again. Alright, so you guys owe me that one. I gotta get back to some stuff one of these days.
Barely anybody knows.
Yeah, no, the computer stuff, that's fine. Then I'll get you guys all back to stuff tomorrow.
Do you
What's
want
up?
me to turn in the wrong problems or redo it and do the right problem?
You honestly think I can make you redo it?
I don't know. Some teachers would.
Am I like other teachers? Really?
Not really.
I say I hope I'm not. I mean,
You act different, but you're like a lot like people like a lot.
What?
yeah. I mean, I know math is one of those things that eventually I'm going to try and get it more to you guys to do. But it's been with all the problems we've had with the computers and all that, I can't do that yet until I know that everything's working right. So don't worry, we'll change it up. I'll keep you on your toes here pretty soon.
No, all of my other teachers are boring.
Well, at least I keep you awake, so thank you.
Sometimes.
Shut. Throw your calculator, I realize those are expensive.
I mean, it could be kind of funny. I mean, it's very opposite.
Right, you know.
It might be frowned.
Great, now I'm gonna get pink eye.
No, no.
All right, so one of the things that I've noticed, just from watching you guys and kind of showing how things are working, I think that what we still have scariness that shows up is when you have so many zeros and things to find, as far as getting the correct setups to go and work through that. The idea that I was thinking about was, I know that we were trying to see if I can squeeze things in to go into testing tomorrow, but that obviously I'm not going to do because I can't give you guys that fast of a turnaround. I don't think it's not fair, but I think what we've gotten to the point where we probably could have. So what I want to do today is kind of mix things together about finding zeros, and then if you have which one was it that had the real zeros? 6, 6, right? Yeah. What I want to do with this is I want to spend some time going through how do you find real zeros, graph it using end behavior, okay? So just kind of mixing a little bit together. So we're going to do find the zeros like with synthetic like we have been. Sometimes you can factor and go through there. But then I want to plot it. I know we've kind of we've done it a couple of times, but I want to make sure you guys understand how to do that because I may or may not ask you that. What's up?
Calculator or no calculator?
Yes.
Yes, calculator.
And yes.
No, that.
A little bit of a mix.
No, like if we have to do this part, will that be calculated?
What do you think?
No.
Correct. So what you were saying about, like, I have some problem sets that I made up the other day that I got to run off next hour to give you guys tomorrow. So we'll probably work on that maybe in class time tomorrow to get that we have a little bit more time together to go through. It's very, I mean, it's all the same stuff. It's factor and find zeros, really. It's synthetic division. Do you guys remember the trick whenever you have 4 terms? What do you always check? Try and see if you can group it. Absolutely. If you have 4 terms, no matter what the degrees are, whenever you have 4 terms, try and see if you can group right away. It's a fast way of doing things. If you have 3 terms and your powers are cut in half and then to nothing, try to try to factor it like you would regular old boring trinomial. Okay, things like that. Those are like those little shortcuts that show up. Let's look at. Excuse me. Which one do I want to do? This one. Let's do this and kind of walk through about how I can do this and graph it given zeros and things like that once it loads. Eventually. Maybe.
Hopefully.
Hopefully. Do-do-do-do. So I want to try 2x cubed plus 4x squared minus 2x minus 4. I want to find all of my zeros. I want to plot them. And I want to graph them, including their end behavior, to kind of get a rough sketch idea of what this looks like. So think about shortcuts that could occur. How many terms are in the, it's a 3rd degree polynomial, how many terms should it have? Should it have 4 of them? Does it have 4? So the minute you notice that it's a 3rd degree polynomial, or even if it was 5th degree or whatever, if you have 4 terms, take 1 second, or 10 seconds, and see if it is possible to factor it the way that it sits, without having to do any of the synthetic division. Because hopefully by now you guys realize that synthetic division is silly quick, and it's really not complicated, right? It's kind of a nice method to remember. But if you can do this, why not just check real quick if you can do GCFs? What's the GCF of 2x cubed and a 4x squared?
2x squared.
Good. It's a 2x squared. I'm left with an x plus 2. What am I going to take out of there? A negative 2. So now I actually was able to factor that out. So I get 2x squared minus 2 and then x plus 2. Which means I can be able to figure out some zeros. What can I do here? Take out the GCF. Since I'm finding zeros, does that constant value of 2, does it matter? Nope. So what are my zeros? What?
What if you do square root plus square root?
You said all
If
zeros.
you take
Not
x squared minus 1, that'd be I. Oh, so it's just 1.
Yeah, this is the difference. This is a minus sign between, because that's the difference of squares. So you'll have x plus 1, x minus 1. If it was a plus sign, then you're. So our 0 is going to be plus minus 1 and negative 2. Are we okay with that? Tails. What do the tails do?
Down.
They're going down up. Everybody okay with that?
Yep.
So I know that my tails are down up, but so I have zeros at negative 2, negative 1, and 1. I also know one other point on this graph without any real hard work to think of. What is it? What's the other point you know on that graph without any really hard thinking? Nope.
Is it the one?
It's the y-intercept. What's your y-intercept?
Negative 4.
Negative 4. Very good. Now, I know that it's my y-intercept because if I substitute in 0 for x, I can always find a y-intercept, no matter what. In this case, it's negative 4. So that's one of the other points that I can always plot. That at least gives me some idea of how far something might dip down as it's curving. Does that make sense? Okay. So we know this is a down-up. So we go up, down, and up. There you go. That y-intercept at least gives it some scope and scale as far as how far it might at least drop down or go up, whether it could be. Okay. What happens if you have this wasn't in this problem, but let's say this was, you had no constant value. What's your y-intercept then? 0. Very good. It's 0. Good. Do this one. Oops, sorry. I'm guessing that this wasn't terrible. You could not group these right away, correct?
No.
Yeah. I give her credit, she's a trooper. So, you use synthetic division. Help me out, which one worked first? Hey, negative 1 worked? Okay. Okay, so that worked right away. Did any of you guys try negative 1 again? Didn't work. Did you use synthetic again, or did you just try to group it? What did you use for synthetic? 2? Yep. Now, could you have grouped that as 2x squared minus 7x plus 6 and figured it out that way? Yep, it works. But if you want to continue with synthetic, that's also fine. So 2, 4, and there you go. So you have 0 at negative 1, a 0 at 2. So your terms are x plus 1, x minus 2, and then this one is 2x minus 3. So your 3 zeros are at negative 1, 2, and 3 halves. Our tails are, again, down, up. And we had a y-intercept at positive 6. So let's see, negative 1, 2, 3 halves, and we'll say 6 is here. Whatever. There you go. The idea is to be able to take some information from the given polynomial basically y-intercepts to figure out your heights on some values and go from there. You're like, you really don't have to, right? I just
I like it.
Yar. Because they hump like a snow hill. They call me Ishmael. What we did?
It's not a pirate, it's a sailor.
It's the same thing.
It's not.
It's not.
How is it not the same thing?
A sailor.
A sailor's like a good, like, honest man. A pirate is a pirate.
A pirate is a pirate.
Can a pirate be an honest man? The dread pirate Roberts? He was an honest man.
No, he was lying to everybody.
But he was an honest man.
Killing people, though.
No, did the dread pirate Roberts kill people? No. He was after his true love.
He's
No.
like debating himself.
I know he's thinking about, wait, I'm not sure what's going on here, but no.
Jack Pirate Roberts did kill people.
Hey, let me show you how this works with a calculator. I know how much fun you guys have using your calculator to solve problems, so I want to do a couple of these as well.
What if
What if I want to let you use your calculator?
what if I don't want to use it?
So, polynomial problems when you're dealing with your calculator trying to find values are very, very easy to work with. It's a matter of knowing how to use your table, okay? Now, like I said, over time we start to use the calculators a little bit here, a little bit there. Now, when we did quadratics, we had some word problems before that had some calculator parts to them. But then again, we also had word problems that you didn't need the calculator at all because it was, like cost, sales, things like that. Well, the one problem, if you recall, that we had with quadratics, think about that candid one. Remember how we were able to figure out how far it went over or how long something was in the air? We were just counting the value of time from starting at 0 time to how long it got across the axis again. That's basically all you're doing with polynomials as well. You're looking for specific values within your tables. So in this problem here, it says for the years 1980 through 96, total exports E in billions of dollars for the US be modeled by blah, where T is the number of years since 1980. So T equaling 0 is what year? 1980. So year 0 is 1980. In what year were total exports about 312.76 billion? Well, gee, what do you think you need to do? Yeah, throw it in your calculator. Seriously, you basically are going to put this function in your calculator.
Then instead of changing
Yeah. So if I put that in my calculator, let's see, it's negative 0.131x cubed. It's 5.033x squared. Minus 23.2x plus 233. Now, do you guys know how to change your table settings? Yeah. So if you go to if you hit the button that says second table set where window is, it's going to ask you where to start your table. We know that year 0 is 1980, correct? So why not start at 0? And some of them do, some of them might not. It depends on what you had in there before. And now go to your table. I know that at 1980, year 0, it's $233 billion. Hey, guess what? If I put in 0 for here, what do you get? Hallelujah. The y-intercept. It works. Okay? So now all you're doing is counting years to figure out when did it hit 312 and change. So 0, 1, 81, 82, and so on. So it happens somewhere between 88 and 89. Everybody see that? In what year did the total exports be about 312? Well, I'm looking at somewhere between, if this is 80, 81, 82, and so on, I'm going to say after 1988 is what I would say. Or between 1988 and 1989, the sales became that, or the exports became that. Does that make sense? That's all you do. It's basically a lot of table work, okay? So what I want you to practice tonight is on, this is the 6-7. Let me write down these numbers for you here. On 6-7, which is page 370, and it was 6.6, I think, was the other one.
Right there.
51, 57.
To what page?
It would be 51, 57. Does that make sense when I say plot and graphs? Remember what we just did in class? Plot the zeros. I know it was a long time ago. I know. But what I mean by that is, for those 4 problems, I just want you guys to practice plotting the zeros and graphing your end behavior. But when you plot those things, what's the other one? Oh, this is from like 2 years ago, so it doesn't matter.
I'll like go
Different.
back to it.
Yeah. The Yeah.
I was happy for a second. I was like, ooh, that's
Yeah, I was looking at old tests to try to, I have a bunch of problems handwritten out. I was trying to see if I had something close to it, with some extra ones and whatnot. We'll talk more about that tomorrow. But yeah, what I want you to do with those 4 problems is plot your zeros, and then graph it with your end behavior. Try to do it without a calculator. Hint, hint.
try. Keyword in that sentence is
Now, can you do that 6.7 stuff without a calculator?
I
No.
mean, probably.
You could, but would you want to multiply all that out by hand? All right, you can do it without a calculator.
Alright, you can do it. You can just calculate
Anybody whose
forever.
name is Maddie has to do it with without a calculator. It's good for you. No,
Wait, but my actual name isn't Matt, so why would I Matt?
whatever. It starts with an M. Anybody's name starts with an M. You're SOL. Shucks out a lot. You're up a creek without a paddle.
Well, good for me.
Okay, does that make sense? All right. I'll have some review stuff for us